In this video, we will be looking at all the questions from the Edexcel GCSE Higher Paper 1, which is a non-calculator paper. Number 1. Work out 8.46 divided by 0.15. We're first going to put this into our division, and the first number always goes on the inside and the second number goes on the outside. We always need to make sure that the number on the outside is a whole number. So in order to make 0.15 into a whole number, we are going to multiply it by 100, which means we also have to multiply the inside number 8.46 by 100. This now gives us 15 on the outside and 846 on the inside, which means we are going to be looking at the 15 times table. Whenever we are looking at the times table of a two-digit number, we can work this times table out by partitioning the number. So this can be partitioned into 10 and 5, which means we're first looking at the 10 times table, so we could quickly write that down. And the 5 times tables would be 5, 10, 15, 20, 25, 30, and 35. To get the 15 times table, what we then need to do is just add both of these. So the first one would give us 15. We would then have 30, 45, 40 plus 20 is 60, and 50 plus 25 is 75, 60 plus 30 is 90, and 70 plus 35 is 105. So now we would need to do 8 divided by 15. 8 is not in the 15 times table, so we put a 0 and carry the 8. 84 divided by 15, we would use 75, which is there 5 times, so we put 5. And to get the remainder, we would just do 84 take away 75, and that gives us 9. So we put the 9 by the 6, which gives us 96. And 96 divided by 15, we would use the 90, which appears 6 times. We have to remember that there's a decimal after a whole number and zeros. So if we do 96 take away 90, that gives us a remainder of 6. So if we put the 6 there, that now becomes 60. And 60 appears in the 15 times table 4 times. So our final answer for number 1 is going to be 56.4. So this is a 3-mark question. We would get the first mark for correctly changing the numbers into whole numbers. We would get a second mark for getting the correct answers, and the third mark for putting the decimal in the correct place between the 56 and the 4. For number 2, it says work out 7 and 3/8, take away 2 and a half. Give your answer as a mixed number. So in order to do this, we would first have to change these into improper fractions. So we will multiply 7 by 8. If we add the 3, that gives us 59. So our improper fraction is going to be 59 over 8. We're taking away 2 and a half, so 2 times 2 gives us 4. And if we add the 1, that gives us 5. Then need to make sure that both the fractions are over the same denominator. So we're going to use the LCM of 8 and 2, which is 8. And the first fraction is already over 8, so we can keep that the same. But in order to make the second denominator into 8, we would have to multiply that by 4. So we are going to do the same thing to the numerator. 5 times 4 gives us 20. And now we can simply take away the numerators. 59 take away 20 is 39. Our denominator would remain 8. So because the question says to give the answer as a mixed fraction, we just have to work out 39 divided by 8. And this would give us 4 with a remainder of 7. So as a mixed number, our answer is going to be 4 and 7/8. This was a 3-mark question. So first, we would get our first mark for writing these correctly as improper fractions. We would get a second mark for correctly writing them with the same lowest common denominator, and our final mark for a correct answer of 4 and 7/8. Number 3. A cube has a total surface area of 150 centimeters squared. Work out the volume of the cube. So the only information that we've been given about the cube is that the total surface area is 150 centimeters squared. In order to find the volume, we need to know what lengths the cube is. And we know that in a cube, all the side lengths are equal to each other. And because we do not know what the side lengths are, we could just call them x for now. In order to find the area of just one of the surfaces, we would have to do the length multiplied by the width, which would just be x multiplied by x, and that gives us x squared. Because the lengths are all equal in a cube, the areas of each surface would also be equal. Therefore, the total surface area would be 6 times x squared because we've got 6 faces in the cube. We now have an expression for the total surface area, and what we can do is make an equation using the information given. The total surface area is 150, so we can substitute that, and that should be equal to 6x squared. So in order to solve this for x, we would first divide both sides by 6. 150 divided by 6 is 25, so 25 is equal to x squared, which means that x would be equal to the root of 25. Therefore, x is equal to 5 centimeters. So in order to find the volume, we would just multiply the length times the width times the height, which would just be 5 times 5 times 5, which is the same as 5 cubed, and that gives us 125 centimeters cubed. This was a 4-mark question, and we would be given 1 mark for knowing how to form an expression for the total surface area, another mark for finding the correct value for the length, a 3rd mark for knowing how to find the volume of the cube, and the final mark for getting the correct answer for the volume. Number 4. The table shows information about the daily rainfall in a town for 60 days. Draw a frequency polygon for this information. So whenever we're trying to draw a frequency polygon for any grouped data, we always have to make sure that we use the midpoints of each of the classes. To find the midpoint, we will just add the two numbers, for example, 0, which is the lower class, and 5, which is the upper class, and then divide it by 2. So the midpoint for the first one will be 2.5, the second one will be 7.5, the midpoint of 10 and 15 is 12.5, the midpoint of 15 and 20 is 17.5, and the midpoint of 20 and 25 is 22.5. We can now plot these points on our graph, and because on our y-axis 10 small boxes represent 10 units, this means that each small box represents 1 unit. For the x-axis, 2.5 would be right in the middle of 0 and 5, so we could plot 2.5 with 8. We will plot 7.5 with 24. We'll plot 12.5 with 13. We will plot 17.5 with 11, and we will plot 22.5 with 4. The final step would just be to join all the points with a straight line so that we have different line segments, and that is our frequency polygon completed. This was a 2-mark question, and in order to get the 2 marks, the first mark would be for knowing that we have to plot the midpoints, and the second mark would be for plotting all the points correctly and joining them up with a ruler. Number 5. The universal set consists of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Set A consists of odd numbers and set B consists of square numbers. Part A. Complete the Venn diagram for this information. So 1 is an odd number as well as a square number, so we can put it in the middle. 2 is neither odd nor square, so we will put it outside of set A and B. 3 is an odd number, so we put it just in set A. 4 is not odd, however it is a square number, so we put it just in set B. 5 is an odd number, so we put it just in set A. 6 is again neither odd nor square, so we put it outside of A and B. 7 is an odd number, so we put it just in set A. 8 is again neither odd nor square, so we put it outside of set A and B. 9 is odd as well as a square number, so we put it in the middle. And 10 is again neither odd nor square, so we put it outside of set A and set B. Part B says, a number is chosen at random from the universal set. Find the probability that this number is in the set B apostrophe, which means not in set B. So this is set B, and if we're looking at all the numbers which are not in set B, that means we're looking at this whole region outside of set B. So if we count the numbers that are in this region, we've got 1, 2, 3, 4, 5, 6, and 7 numbers. So because we're writing this as a probability, we're going to put 7 as our numerator, and there are 10 numbers in total, so we will put 10 as our denominator. So for part A, we would get 3 marks for putting in all our numbers in the correct places in the Venn diagram. And for part B, we would get 1 mark for correctly writing our probability and the correct numbers in the numerator and denominator. Number 6. This cartograph shows information about the ages and weights of some babies. Part A, describe the relationship between the ages and weight of the babies. So for part A, we can say that there is a positive correlation, which means that as the baby's age increases, the weights also increase. The next part says, another baby has a weight of 5.8 kg. So for part B, it says using the scatter graph, find an estimate for the age of this baby. So whenever we're using our scatter graph to find any estimate, we first have to draw a line of best fit. So we could draw our line of best fit there, and because we're looking at where the weight is 5.8, that means we're looking at the y-axis and finding 5.8 there. So we can see that if 10 boxes are representing 2 units, that means one box will represent 0.2 units. And we know that 5 would be somewhere in the middle of 4 and 6, so that's where 5 would be. And if we count in 0.2s, 5.8 would be there. So we can just take our ruler and draw a line at 5.8 until it meets the line of best fit. We then want to see what value that corresponds to on the x-axis to see what age that corresponds to. So if we read the scale, this is also going in 0.2 units. So for part B, we can say that the estimate of the age is 3.6 months. So in this question for part A, we would get 1 mark for stating the correct relationship, and in part B, we would get the first mark for drawing the correct line of best fit, and the second mark for giving a correct estimate of the age. Number 7. The price of a holiday increases by 20%. This 20% increase adds £240 to the price of the holiday. Work out the price of the holiday before the increase. So we know that whenever we are looking at an original amount of anything, that always represents 100%. For this question, we are adding 20%, which makes our new percentage 120%. We've been told that the 20% increase adds £240, which means the 20% represents £240. So in order to work backwards and look at what the 100% would be, we can check what we have done to 20 to make it into 100, and we can see that we have multiplied that by 5. This means that if we want to find the original amount, we would also have to multiply that by 5. So if we try to work that out, 240 multiplied by 5, we can first do 24 times 5. 4 times 5 is 20, and 5 times 2 is 10, plus the 2 is 12, which means 240 times 5 will be 1,200. So our final answer for this question is £1,200. We would get 1 mark for being able to recognize that we have to multiply by 5, and the second mark for getting a correct final answer of £1,200. Number 8. The diagram shows a solid cylinder on a horizontal floor. The cylinder has a volume of 1,200 centimeter cubed, height of 40 centimeters. The cylinder exerts a force of 90 newtons on the floor. Work out the pressure on the floor due to the cylinder. So here we've been asked to work out the pressure, and we have been given the formula for the pressure, which is force over area. We've also been given the force in the question, which is 90 newtons. So we've got the force, however, we do not have the area. We do know that the area which is exerting the pressure on the floor is a circle, and we know that the area of a circle is given by pi r squared. The only other information that we've been given is the volume and the height. We also know that the volume of a cylinder is given by the formula pi r squared times h. So if we substitute what we know in that formula, we know that the volume is 1200, and this will be equal to pi r squared times the height, which is 40. If we divide both sides by 40, we can simplify this to 120 divided by 4, which is 30, which means that 30 is equal to pi r squared. We already know that the formula of the area of a circle is given by pi r squared, and we have 30 is equal to pi r squared. We can therefore conclude that the area is equal to 30 centimeters squared. We now know what the area is, and we can use this to now find the pressure that we're looking for. Pressure is equal to force over area. The force is 90, and the area from our previous formula is given to us as 30. We can simplify this to make it 9 over 3, and 9 over 3 is equal to 3 Newton per meter squared. So here we would get 1 mark for identifying that 30 is the area of the circle. We will get another mark for putting the values correctly into the formula, and the final mark for getting a correct answer of 3 Newton per meter squared. Number 9. Use these graphs to solve the simultaneous equations 2 minus 2y is equal to x and 2y is equal to 3x minus 22. Whenever we are solving simultaneous equations graphically, we just need to look at where both the line graphs intersect. So the first line graph has been given to us, and the second line graph has also been given to us. This is the point of intersection, and if we read the x-axis, the x-coordinate there would be 6. The y-coordinate here would be minus 2. So we can just write this as our answer, where x is equal to 6 and y is equal to minus 2. So this was a 1 mark question, and we would get the full 1 mark for giving both the correct coordinates for x and y. Number 10. Here is a pentagon. Angle AED is equal to 4 times angle ABC. Work out the size of angle AED. You must show all your working. So we know that to find the angles in any polygon, we would have to use the formula 180 times n minus 2. In a pentagon, we've got 5 sides, so we would do 180 times 3, which gives us 540. This tells us that all the angles in this pentagon should give us a sum of 540. The other piece of information that we've been given is that angle AED is equal to 4 times the angle ABC. We do not know the value of any of these angles, so for now we can just call angle ABC x, and so if angle ABC is x, that would mean angle AED is equal to 4 times x, which would be 4x. So what we can do now is, using all these angles, we can form an equation and then solve the equation to find x. So we can write this as 120 plus 135 plus 110 plus 4x plus x is equal to 540. So if we first add 120, 135 and 110, that gives us 365. So we can now write this in a simplified form as 365. 4x plus x is 5x, so we can write 365 plus 5x is equal to 540. If we then minus 365 on both sides, we will have 5x is equal to 540 minus 365, and that gives us 175. So 5x is equal to 175, and if we divide both sides by 5, this would give us 35. So this means x is equal to 35. The question was asking us to find the size of angle AED, and we know that angle AED was equal to 4x. So if we just do 4 times the x, which we got, which is 35, we get 140. So our final answer for this question is 140. So the first mark in this question would be given for identifying that the angles in a pentagon add up to 540. The second mark would be for identifying which angle is x and which one would be 4x. The third mark would be for forming an equation and being able to solve it. And the last mark would be for getting the correct answer for the angle AED. Number 11, write 6x to the power 5 y cubed, everything squared, over 3x squared y to the power 7 times 4xy to the power minus 3 in the form ax to the power b, y to the power c, where a, b, and c are integers. So for the numerator, everything is to the power 2, which means that the numerator would all have to be squared. So 6 squared gives us 36. X to the power 5 squared means we would have to multiply the powers, which would give us x to the power 10. Y cubed and then squared would also mean we would have to multiply 3 and 2, which gives us y to the power 6. We are then dividing it by the denominator, and in the denominator we can see we have two expressions that we are multiplying. So first we would just multiply 3 and 4, which would give us 12. X squared multiplied by x would give us x cubed. And when we multiply numbers with indices, we have to add them. So when we do y to the power 7, add y to the power minus 3, we would have y to the power 4. We now have two expressions that we are dividing, so we can divide the numbers first. 36 divided by 12 would give us 3. X to the power 10 divided by x to the power 3 would mean we have to take away. So 10 take away 3 is 7. So we would have x to the power 7. And for the y powers, we would also have to take away. So 6 take away 4 would give us 2. So our final answer for this question is 3x to the power 7 y squared. So the first mark would be for simplifying the numerator correctly. The second mark would be for simplifying the denominator correctly, and the third mark would be for getting a correct final answer. Number 12. Martha plays a game twice. The probability tree diagram shows the probabilities that Martha will win or lose each game. Find the probability that Martha will lose at least one game. So first, we need to look at what each branch of this probability tree is representing. If we follow the first branch, that is telling us that she will win both games. The second one would be a win first, then a lose. The third one would be a loss and then a win. And the last one would be 2 losses. The question is asking us to find the probability that she will lose at least one game, which means we are looking at the probabilities in all these 3 branches. So there are 2 ways to do this question. The first way is that we could find all 3 probabilities and then add them up. However, we know that the probabilities in our probability tree diagram need to all add up to 1. So an easier way to do this is to just find the probability of her winning both games and then take it away from 1. So the probability of winning both games would be given by 5 over 8 multiplied by 2 over 9, and that would give us 10 over 72. So to find the probability that she will lose at least one game, we can just take it away from 1. Because our denominator is 72, we can write this as 72 over 72, and now take away from 10 over 72, and this would give us 62 over 72. We can simplify that fraction or we can leave it as it is. So here we would get the first mark for identifying what each branch represents and which branches we would be needing for this question. The second mark would be for calculating the probabilities correctly, and the third mark would be for getting a correct final answer. Number 13. Y is directly proportional to X. Y is equal to 24 when X is equal to 1.5. Work out the value of Y when X is equal to 5. So in order to write Y is directly proportional to X, we will write it as Y is equal to Kx. However, we don't know what the value of K is, so we will use these initial conditions that we've been given in order to find X. So we will substitute Y as 24 and put it equal to K times 1.5. So to find K, we would have to do 24 divided by 1.5. However, 1.5 is a decimal number, so to do this without a calculator, we can change it into a whole number by multiplying both the numerator and denominator by 2, because we know that 1.5 times 2 will give us a whole number of 3. So 24 multiplied by 2 can be written as 48, and in the denominator we will put 3. 48 divided by 3 is 16, which means K is equal to 16. The question is asking us to work out the value of Y when X is equal to 5, so we can now write an equation for Y with our value of K. Y would be equal to 16x, so when X is equal to 5, Y would be equal to 16 times 5, and that would give us 80. So Y is equal to 80. So the first mark would be given for finding the value of K, the second mark for substituting K correctly into the equation, and the third mark for getting a correct final answer of 80. Number 14. Write 1 over 16 in the form 4 to the power n, where n is an integer. So 1 over 16 can be written as 1, and if we change the 16 into a base of 4, we can write it as 4 to the power 2. However, if we remove 4 from the denominator and bring it to the numerator, our power becomes minus 2. Therefore, we can say that n is equal to minus 2. So our final answer would be 4 to the power minus 2. For part B, we are told to work out the value of 8 to the power 5 over 3 minus 9 to the power 3 over 2. So in this question, our base numbers are both different. One is 8 and the other one is 9, which means in order to work this out, we would have to first work out the value of each term separately. So first, we can work out 8 to the power 5 over 3. This means that we first have to do 8 to the power 1/3 and then put 5 outside the bracket. 8 to the power 1/3 just means the cube root of 8, which is 2, and we've still got the power 5. So 2 to the power 5 is equal to 32. To work out 9 to the power 3 over 2, we are first going to put 9 to the power half and put the 3 outside the bracket. 9 to the power half simply means square root of 9, which is equal to 3, and we've still got the power 3 as well. So 3 cubed is equal to 27. So our 8 to the power 5 over 3 can now be written as 32, and we are taking away from 9 to the power 3 over 2, which can now be written as 27. So 32 take away 27 gives us 5, and our final answer for this question will therefore be 5. So here we would get 1 mark for working out 8 to the power 5 over 3, a second mark for working out 9 to the power 3 over 2, and a third mark for getting a correct final answer of 5. For part A, we would also get 1 mark for writing 4 to the power minus 2. Number 15. The equation of a line L is y is equal to 2x minus 5. The equation of line L2 is 6y plus kx minus 12 is equal to 0. L1 is perpendicular to L2. Find the value of k. You must show all your working. So for L1, we know that 2 is going to be the gradient. So we can just note that by writing down that the gradient of L1 is equal to 2. And for L2, we first need to put this equation in the form y is equal to mx plus c in order to find the gradient. However, we've also been told that L1 is perpendicular to L2, which means that the gradient of L2 is going to be the negative reciprocal of L1, which will make it negative a half. If we now try to make y the subject in the equation of L2, we've got 6y plus kx minus 12 is equal to 0. If we move kx and minus 12 onto the right-hand side, that would give us 6y is equal to minus kx plus 12. And if we make y the subject, we would have to divide everything by 6. And 12 over 6 can be simplified and written as 2. So from this equation, our gradient is minus k over 6. We also know that the gradient of L2 should be equal to minus a half, and therefore we can say that minus k over 6 is equal to minus a half. If we multiply both sides by 2, we will get minus 2k, and if we now multiply both sides by 6, we will get minus 2k is equal to minus 6. If we then divide both sides by minus 2, we will have a final answer of k is equal to 3. So this was a 3-mark question, and we would get the first mark for identifying that the gradient of L2 is the negative reciprocal of L1. We would then get another mark for correctly making y the subject in the equation of L2. And the third mark for getting the correct answer of k is equal to 3. Number 16. Here's a sphere. 3/8 of the surface area of this sphere is 75 pi centimeters squared. Find the diameter of the sphere. Give your answer in the form a root b, where a is an integer and b is a prime number. So first, we've been told that 3/8 of the surface area of this sphere is equal to 75 pi. So if 3/8 of the surface area is 75 pi, that means that we would first have to look for the whole surface area, which would be 8/8. So we would now need to check what we did to 3/8 in order to make it 8/8, which means we have multiplied 3/8 by 8 over 3. Multiplying this would give us 1 whole, and we've simply written 1 whole as 8 over 8. Which means we would also have to multiply 75 pi by 8 over 3. So if we do 75 pi times 8 over 3, we can first simplify by dividing this by 3. So 3 divided by 3 is 1, and 75 divided by 3 is 25. We then need to do 25 pi times 8. So if we work that out, we will get 200. So this is equal to 200 centimeters squared. The question is asking us to find the diameter of the sphere, and we now have the whole surface area of the sphere, so we can use this formula that we've been given to substitute whatever values we know. So first, we know that the total surface area is equal to 200 pi, so we can substitute that underneath surface area. 200 pi would be equal to 4 pi r squared. So in order to find the diameter, we can first find the radius using this formula. So if we divide both sides by 4 pi, the pi's cancel out on all the sides, and 200 divided by 4 gives us 50. So 50 is equal to r squared. We've been told in the question to give the answer of the diameter in the form of a root b, and a needs to be an integer and b needs to be a prime number. So if we write r would just be root 50, and as we can see, 50 is not a prime number, which means we would have to simplify this surd. So we can now write this as root 25 times 2, and root 25 can be written as 5, and the root 2 is a prime number, so we can just write this as 5 root 2. However, the question was asking us to find the diameter, and this is just the value of the radius. So to find the diameter, we can just multiply the radius by 2. So if we multiply 5 root 2 times 2, this will give us 10 root 2. And this is our final answer for this question. So we would get the first mark for finding the total surface area of the sphere, which is 200 pi centimeters squared. The second mark would be for finding the correct radius of root 50. The third mark would be for simplifying the surd of root 50. And the fourth mark would be for getting a correct final answer of 10 root 2. Number 17. Make x the subject of the formula y is equal to 4 times 2x minus 7 over 5x plus 3. So the first thing we're going to do is try and get rid of the denominator by cross-multiplying and making it a linear equation. So we would have y times 5x plus 3 is equal to 4 times 2x minus 7. If we then expand this bracket, we would have 5xy plus 3y is equal to 8x minus 28. We can now see that we've got x terms on both sides of the equal sign, but we need to make x the subject, which means we would have to collect all the x terms onto one side. So if we minus 8x on both sides, this will give us 5xy minus 8x plus 3y is equal to minus 28. If we then minus 3y on both sides, we will have 5xy minus 8x is equal to minus 28, take away 3y. So just to make the setup look a little bit better, because we've got both minuses on the right-hand side, we can divide all through by minus 1, which will now make our equation minus 5xy plus 8x is equal to 28 plus 3y. We can again rearrange that just to write 8x minus 5xy is equal to 28 plus 3y. So to make x the subject, because x is in two terms, we can factorize x outside, so we put x and a bracket. To make x into 8x, we would have to multiply by 8, so in the bracket we put 8 and minus 5y, and this is equal to 28 plus 3y. We can now divide both sides by 8 minus 5y. So if we divide that, the brackets on the left-hand side cancel out, and we are left with x is equal to 28 plus 3y divided by 8 minus 5y. So this was a 4-mark question, and we would get the first mark for getting rid of the fraction and setting up a linear equation. The second mark would be for collecting all the x terms on one side. The third mark would be for factorizing x, and the fourth mark would be for correctly making x the subject. Number 18. 7 kgs of carrots and 5 kgs of tomatoes cost a total of 480p. Cost of 1 kg of carrots to cost of 1 kg of tomatoes is equal to 5 to 9. Work out the cost of 1 kg of carrots and the cost of 1 kg of tomatoes. So using this ratio, we can first set up an equation for the cost of 1 kg of carrots, which we can call C, and 1 kg of tomatoes, which we can call T, as being equal to 5 to 9. We can now write this as a fraction, so we can set up a linear equation and write C over T is equal to 5 over 9. We are then told that 7 kgs of carrots and 5 kgs of tomatoes cost a total of 480p. So we can write this as 7 times C, because T is representing 1 kg, plus 5t, because T is again representing just 1 kg of tomatoes, and this total should be equal to 480. Using the ratio that we have set up, we can now cross-multiply it so that we can set up a linear equation, which would give us 9c is equal to 5t. If we then divide both sides by 5, we can write t is equal to 9c over 5. And what we can now do is, because we've got an equation for t, we can now substitute t in terms of c. So we can rewrite our equation as 7c plus 5 multiplied by 9c over 5 is equal to 480. So what we have done is just substituted our t as 9c over 5. And if we now try to simplify this fraction, we can cancel out the 5's and we can rewrite this as 7c plus 9c is equal to 480. If we simplify this, we will get 16c is equal to 480. And if we divide both sides by 16, c is equal to 480 divided by 16, which would be 30. So as we had written earlier, C was representing 1 kg of carrots, and now we have found that 1 kg of carrots is equal to 30p. Now that we know C, we can substitute this value into this simpler equation that we had and work out the value of t. So we can write t is equal to 90 times 30 divided by 5, which would give us 270 divided by 5. And if we work that out in the bus stop, we would have t is equal to 54p. So 1 kg of tomatoes is equal to 54p. So this was a 4-mark question, and we would get the first mark for setting up a correct equation for the total of the 7 kg of carrots and 5 kg of tomatoes. The second mark would be for setting up an equation using the ratio that they've given us. The third mark would be for finding a correct value of 30 for our 1 kg of carrots. And the last mark would be for finding the correct value for the 1 kg of tomatoes. Number 19. The menu in a restaurant has starters, main courses, and desserts. There are 5 starters, there are 12 main courses, there are X desserts. There are 420 different ways to choose 1 starter, 1 main course, and 1 dessert. Work out the value of X. So we know that whenever we're looking for combinations, we do have to use the product rule. And we have 5 starters, so we are going to do 5 multiplied by the number of main courses, which is 12, and again multiply that with the number of desserts, which is X. This should give us the 420 different ways in which we can choose the starter, main course, and dessert. So if we simplify this equation, we will now have 60x is equal to 420. And if we divide both sides by 60, we will have 420 is divided by 60, which gives us 7. So we would get 1 mark here for being able to form an equation using product rule. And our final mark would be for getting a correct answer of x is equal to 7. Number 20. For x is greater or equal to 0, the functions f and g are such that f of x is equal to 3x plus 4, g of x is equal to the square root of x plus 2 over 5. Part A, find g inverse of x. So we would first have to equate g of x to y and write this as y is equal to the root of x plus 2 over 5. Finding the inverse function means we have to make x the subject, so we would multiply both sides by 5, and this would give us 5y is equal to the root of x plus 2. We can then minus 2 on both sides, which gives us 5 minus 2 equal to root x. And if we now want to take the x out of the root, we would have to square everything on both sides. And this would give us 5y minus 2 squared is equal to x. We would now have to change the x into y, or we can rewrite it as g inverse of x. So our g inverse of x will now be 5x minus 2 squared. Part B. Solve g of f of x is equal to 3. What this means is that we have to put f of x into the g function. and then equate all of this to 3. So we are first going to write the g function, and wherever we've got x, we are going to substitute that with the f function. So our g function is the root of x, but this time, instead of x, we are going to put 3x plus 4, which is the f function, and then we are going to put the plus 2 and over 5. The gf of x is equal to 3 in this question, and that's what we have to solve. So we are going to make this equal to 3. And we're going to write this as 3 is equal to the root of 3x plus 4 plus 2 over 5. If we now multiply both sides by 5, we would get 15 is equal to the root of 3x plus 4 plus 2. If we take away 2 on both sides, we will have 13 is equal to the root of 3x plus 4. We now need to get rid of the square root, so we would have to square both sides. 13 squared is 169, so we can write this as 169 is equal to 3x plus 4. And if we minus 4 on both sides, we will have 165 is equal to 3x. We can now divide all through by 3, which will give us x is equal to 55. So in part A, we would get the first mark for equating g of x to y. The second mark would be for correctly making x the subject and finding an expression of g inverse of x. For part B, we would get the first mark for correctly substituting f of x into the g function. We would get a second mark for being able to form a linear equation from this. And the final mark would be for correctly solving this linear equation and getting a final answer of x is equal to 55. Number 21. A, B, and D are points on a circle with center O. CDE is the tangent to the circle at D. Work out the size of angle ADC. Write down any circle theorems you use. So we are looking for this angle ADC, and we can call that X for now. And the first circle theorem that we can see is that angle BOD is an angle at the center, and angle BAD is an angle at the circumference, which means that angle BAD is going to be half of 64, which is 32 degrees. And the circle theorem that we can state for this is that the angle at the center is always twice the angle at the circumference. As we can see, we now have a small triangle here, and in order to find the missing angle in the triangle, we can do 180 take away the sum of 32 and 51, which is the same as 180 take away 83, and that gives us 97 degrees. And the reason that we can state for this is that angles in a triangle, which we know add up to 180. So we can also label this angle 97. And because we have an angle that is vertically opposite to it, this angle is also going to be 97 degrees. We can then see this other small triangle, and in order to find that missing angle, we are going to do 180, take away 64, and 97 added together, which is the same as 180 take away 161, and that gives us 19 degrees. And the reason for this is also angles in a triangle. We can now see that OD is a radius and CDE is a tangent. The circle theorems tell us that the radius meets the tangent at 90 degrees, which means the whole of angle CD needs to be 90 degrees. In order to find the angle ADC, we would therefore have to take away from 90 angle ADO, so we can do 90 take away 19, and that gives us 71 degrees. And the reason for this is that the tangent meets the radius at 90 degrees. So the final answer for this question is 71 degrees. This was a 4-mark question, and we would get the first mark for finding angle BAD, which is 32 degrees. The second mark for finding the two angles of 97 degrees. the third mark for finding angle ODA as 19, and our final mark for finding angle ADC as 71 degrees. Number 22. ABCDEFG is a cuboid. AF is equal to 6.8 centimeters. FC is equal to 13.6 centimeters. Work out the size of the angle between FC and the plane ABCD. So because we are working out the angle between FC and the plane ABCD, we are first going to draw a line going from F to C. And the second thing we are looking at is the plane ABCD. And because we're looking for the angle between FC and this plane, we are going to draw a line going across from C, because that is the point where FC meets the plane. And we're going to do a line going across to A. So this shows that this is the angle we are looking for, and we can call it X. So we can first sketch out FAC as a right-angled triangle. And we know that AF is 6.8 centimeters and FC is 13.6 centimeters. And we can label the angle we're looking for X. If we label our sides, we can see that the 6.8 is the opposite and FC is the hypotenuse, which means we would be using the function of sine x, which is equal to opposite, which is 6.8, over the hypotenuse, which is 13.6. If we simplify 6.8 and 13.6, we can divide both these numbers by 6.8, and this will give us sine x is equal to a half. Because this is a non-calculator paper, we would now have to use our exact trigonometric values, and we know that sine of 30 gives us a half, which means that x is therefore equal to 30. This was a 2-mark question, so we would get the first mark for identifying the correct trigonometric function of sine x and writing the correct values for the opposite and hypotenuse, and we would get a second mark for getting a final answer of x is equal to 30 degrees. Number 23. Write 3 root 3 over 4 minus root 3 minus 2 over root 3 in the form a root 3 plus b over c, where a, b, and c are integers. Here we're taking away 2 fractions, so the first step is going to be to make the denominators the same. So we can first rewrite the fractions, and we would first have to multiply the first fraction by root 3 and the second fraction by 4 minus root 3. This makes our denominators the same. So for the first fraction in the numerator, the 3 would remain, but the root 3 times root 3 would just become a 3, so we can write this as 3 times 3. And in the denominator, if we do 4 times root 3, that gives us 4 root 3, and the root 3 multiplied by the minus root 3 would just give us minus 3. For the second fraction, if we do 2 times 4 in the numerator, we would get 8, and 2 times minus root 3 would give us minus 2 root 3. In the denominator, 4 times root 3 would give us 4 root 3, and root 3 times minus root 3 would again give us minus 3. Because both the denominators are now the same, we can combine this as a single fraction and keep the denominator 4 root 3 minus 3. So in the first numerator, we have 3 times 3, which gives us 9. We then have the minus 8, and then we have minus 2 root 3, which would now become plus 2 root 3. If we simplify the 9 minus 8, we would now have 1 plus 2 root 3 over 4 root 3 minus 3. The question says that our answer is needed in the form a root 3 plus b over c. So as we can see in the numerator, we already have a root 3, which is our 2 root 3, and we have a plus b, which is the plus 1, but our denominator also needs to be just an integer. This means that we would now have to rationalize this third. And to do that, we would have to multiply both the numerator and denominator by 4 root 3 plus 3. So in the numerator, if we expand that, 1 times 4 root 3 is 4 root 3. 1 times 3 is 3. 2 root 3 times 4 root 3. So if we first do 2 times 4, that gives us 8. And the root 3 times root 3 would give us just 3. And 2 root 3 multiplied by 3 would give us plus 6 root 3. In the denominator, if we first do 4 root 3 times 4 root 3, we can do 4 times 4, which gives us 6. And the root 3 times root 3 gives us 3. 4 root 3 times plus 3 gives us plus 12 root 3. If we do minus 3 times 4 root 3, that gives us minus 12 root 3. And the minus 3 times 3 gives us minus 9. So as we can see in the denominator, we now have a 12 root 3 minus 12 root 3, which would just be 0. So we can cancel those out. And we can now just collect the like terms in the numerator. So for the numerator, we first have 4 root 3 plus 6 root 3, and that would give us 10 root 3. We then have 8 times 3, which is 24. So if we add that on to the 3 in the numerator, that would give us 27. In the denominator, we then have 16 times 3, which is 48, and we have minus 9. So if we do 48 minus 9, that gives us 39. So this is our final answer for question 23, because we now have the answer in the form a root 3 plus b over c. So the first mark in this question would be given for making both the denominators the same. The second mark would be for correctly writing everything as a combined single fraction. The third mark would be for correctly rationalizing the third. And the final mark would be for getting a correct final answer. Number 24. Find the set of possible values of x for which 4x squared minus 25 is less than 0 and 12 minus 5x minus 3x squared is greater than 0. You must show all your working. So first we need to find the solutions to the first inequality, and in order to do that we would first have to find the solutions by equating this to 0. So as we can see, this is a difference of 2 squares, so we can factorize this as 2x minus 5 and 2x plus 5. And this is equal to 0, so if we find the solutions for this, the first solution would be x is equal to 5 over 2, and the second solution would be x is equal to minus 5 over 2, which is the same as 2.5 and minus 2.5. So if we sketch this graph to see where the roots are, or the solutions would be at minus 2.5 and 2.5. Because the inequality is asking us to look at the values which are less than 0, we will be looking at the bottom section of the graph here. So if we write this range as an inequality, we can put x is less than 2.5 and minus 2.5 is less than x, which means x lies between both these values. So we have now found the set of possible values for the first inequality, and in order to look for the set of possible values for the second inequality, we can see that this is a quadratic equation, so we could first rewrite this with our x squared term at the start, which would be minus 3x squared minus 5x plus 12, and this is greater than 0. If we now divide all through by minus 1 in order to make our coefficient of x squared positive, this inequality would now be 3x squared plus 5x minus 12, but because we have divided this inequality by a negative number, the sign would also change and now become less than 0. To find the solutions for this, we can equate it to 0. And to solve it, we can first start by looking for two numbers that multiply to give us minus 36, and the same two numbers need to add to give us 5. So looking at the factors of 36, we have 1 and 36, 2, 18, 3, 12, 4 and 9. And we can use 4 and 9 because we're multiplying to get minus 36 and adding to get 5. That means the 4 would have to be negative, so we will be using negative 4 and 9. We can now factorize this by splitting the middle term. So we can write this as 3x squared plus 9x minus 4x minus 12 is equal to 0. So we can write 3x because that is the common factor between 3x squared and 9x, and then we can open our bracket and put x plus 3. We can also put x plus 3, and in order to make x into minus 4x, we would have to multiply it by minus 4, and minus 4 times 3 also gives us minus 12. This means that our two factors for this equation would be 3x minus 4 and x plus 3, and this is equal to 0. X would be equal to 4 over 3, and x would be equal to minus 3. So also for this, we would now have to sketch the graph to see where the roots or the solutions are, and we can see that the solutions will be minus 3 and 4 over 3. And also for this inequality, we are looking for the section which is less than 0, which means we are looking at the bottom section of this graph. So we can write the range of these solutions as x is less than 4 over 3 and minus 3 is less than x, which means x lies between minus 3 and 4 over 3. The question was asking us to find the set of possible values which satisfy both of these inequalities. So for the first one, we can see that our solutions were between minus 2.5 and 2.5. And for the second equation, our x lies between minus 3 and 4 over 3, and we can write 4 over 3 as a decimal so that we can compare it with the decimals in the first inequality, and we can write 4 over 3 as 1 over 3. So if we label minus 3 and 1.3 on this same number line, minus 3 would be there and 1.3 would be somewhere approximately there. And that is where x lies for the second inequality. However, because we are looking for the set of values which satisfy both inequalities, that means that we are going to be looking for the area in which there is an overlap of both of these, which means this is the only area in which x lies for both of these inequalities. So we can use the minus 2.5 from the first inequality and the 1.3 from the second inequality. And we can rewrite this now as a fraction instead of 1.3. And for the minus 2.5, we can also put it as minus 5 over 2. So we have used the minus 2.5 from the first inequality and the 4 over 3 from the second inequality, because this is where the overlap begins and ends. So our final answer will be minus 5 over 2 is less than x, which is less than 4 over 3. So this was a 5-mark question. We would get the first mark for finding the correct solutions for the first equation and writing them as an inequality. The third mark would be for finding the correct solutions for the second equation and writing the solution correctly as an inequality. And the final mark would be for writing the correct set of values which satisfies both of these inequalities.